Hello, everyone. My name is Bhavani from Amrita University in India. I would like to start by thanking the program organizers for this very relevant workshop and for the opportunity to present. I'm eager to draw your attention to some of the challenges that we have faced in our work towards realizing the SDGs and to share in particular the work in robotics that we have been doing in our corner of the world. As I mentioned, I am from Amrita. I say Amrita with pride because we have a very unique approach to research. Our research mandate is compassion-driven research. Indeed, we do believe that to achieve the SDGs, we need to have this value etched at the foundation of all our efforts. Our chancellor says that there are two kinds of poverty. One is the lack of food, clothing, and shelter, and the other is a lack of love and compassion. It's only when we address the second kind of poverty first, we automatically address the first kind of poverty. For a compassionate person will work towards ending the suffering of others, human and the ecosystem that they live in. So instead of starting with a technical problem and then finding potential uses, we often start with a humanitarian problem and then try to find innovative solutions that brings together the sciences, humanities, and technology. At Amrita, our work in robotics spans medical sciences to security to education and skill development. And especially at Amachi Labs, the research group that I head at Amrita, we work on a rather large problem. A very large percentage of the Indian population lives below the poverty line, and over 90% of this population are employed in informal work and labor, which is plagued by minimal income, unsafe working conditions, unskilled workforce with low literacy levels involved in work that may soon be replaced by automation, and in some trades in the near future by robots. To address this daunting problem of 900 million Indians to be skilled by 2030, the government of India has constituted a new ministry, the Ministry of Skill Development and Entrepreneurship. The challenges in skilling this really large population is not just in the numbers. There are over 2,000 trades with a serious dearth of skilled trainers. Those trainers are employed by industries and are rarely available to train on the ground. Oftentimes, the training includes outdated curriculums that is made even further irrelevant by rapid changes in technology. Another huge problem is social stigma and caste association with different trades. To add to the mix, we have, of course, low levels of literacy as well as a gender bias. Not to mention that the percentage of women in India that are not engaged in gainful employment is over 70%. And this comes along with other development issues like a lack of access and opportunity to infrastructure and training providers. In 2009, we started our journey to see how best we could scale vocational education to reach the poorest and underserved masses in India. Teaching physical skills using technology became the first big challenge. Using these technologies to train women in rural communities became the second. It's because we love to complicate things for ourselves. And the third we figured as we went along was the need to nudge people into actually building aspirations along human rights and basic human needs. And we found that, of course, this was far easier to do with women simply because every woman wants the best for her child. We started with training people in trades that formed part of what was then the most common part-time employer of rural folk, both men and women, in informal, unskilled labor, which is the construction sector and the construction industry. There was a significant need for skilled labor as well. So we figured that we could upskill people in this informal sector with some skills that was that was very much in line with the work that they were doing currently. So we started with plumbing. The reason we chose plumbing was that it was a trade that had a very strong social taboo associated with it. Even if it paid better than other skills in the same trade, there's very strong caste identification with the skill. And our added challenge here was to create and use a technology that could transcend these social barriers, as well as address all other challenges that I have mentioned, both in scale and in cost. So we categorized about 500 tools that form a part of the construction trade. We used 3D programming, haptic feedbacks to build our first cost-effective simulators that could train a person in skills that are needed to handle tools safely, and effectively use about 18 different tools in the construction trade. We call this device the APTAH, or the linear haptic device. It's a Sanskrit word. APTAH is a Sanskrit word for that means touch. So it's very close to haptos, if you notice. So as time went by, our simulators got more sophisticated, and we added machine learning, embedded the skill intelligence of master craftsmen into the tools that actively provided guidance to the users. The slide shows this a simulator that trains people in rebar bending skills. These simulators are actually being actively used by industry in the L&T training centers, L&T being one of the largest companies in the construction sector in India. But with all this, we had just only touched the very tip of a gigantic iceberg. To actually get this technology to make any difference to the SDGs, there was still a very long way to go. Of course, this included the design of new interfaces, the design of blended learning, flipped classroom models that could be set up under the shade of tree with or without internet, or one that was comfortable for women of any age in rural communities to use. When we started with plumbing as our trade, our first work in that area was really with women in peri-urban areas. As we transitioned to more rural areas, we saw that there were no toilets or running water even in these villages. There's more SDG problems here. So we then tailored our tools around this problem, training rural women to build and maintain their own toilets. This involved, of course, training in plumbing, masonry, and plastering skills, as well as parallelly building awareness and the need for hygiene and clean drinking water in the first place. So we had to understand also how rural people react and interact with robots, which also led us to several HRI studies. The one that is being presented in this slide shows the study of a water-carrying robot. It did not matter that the robot had a male voice. Most of the people, rural people, assigned a feminine gender to the robot, as it was always the women who would go to fetch water in a village. Lessons for us all to actively bear in mind while designing robots, that we must be conscious of the biases we built into a robot and the biases that that are inherent within the minds of people that emerge when they react with robots. Often biases that we must actively strive to remove or neutralize while designing or building or implementing robots. With hygiene came the basic need to wash hands properly. This led us to build a simple, low-cost robot operated in a Wizard of Oz mode that interacted and encouraged children to wash their hands in schools. This bit of work became even more significant with the onset of COVID-19. There's so many more such products and studies that I will not have the time to touch upon right now that form the bulk of our work in this space across Amrita and across Amrita at large. But I said our work barely touches the tip of an iceberg. One of the more recent works, however, will be showcased in the poster presentation. Do take a minute to watch and provide your feedback. It's the Hakshi robot. Our future work involves exploring skill intelligences to be able to capture, analyze, and to use that to train people in multiple intelligences. At the end of the day, you can so easily build technology that can be used to make money from natural resources, exploiting it, and change the way the whole world works around your intervention by setting up an entire industry around it and then call it sustainable. Or you can start with the fundamental problems of human suffering and environmental abuse and build technologies to reduce or eradicate that. Can we then redefine the words cost benefit and cost effective to mean what is the cost to the environment? Does benefit mean benefiting the physical and mental being of both the human and the environment? And does effectiveness then mean on how well we can achieve one without compromising on the other? The difference really would lie in the approach, an approach that has compassion at the heart of it. Now, I leave you to reflect on the question, which approach do you think would really achieve the SDGs? I thank you all for taking the time to listen to this talk, and questions are most welcome. Your reflections and your comments would be deeply appreciated, as will possible collaborations. So look forward to hearing from you, look forward to working with you in the near future for a better world for all of us.